Alright, today let's look at trying to reverse engineer or measure up something similar to casting like this using ProbeIt for UCNC. Alright, we have our casting part loaded up here. I've set it up on its side so we can kind of get the main primary shape outline traced. We'll do that in the XY plane going around the part. And we'll be able to pick up and locate a couple of these holes on this side. So the first thing we need to do before we get going is kind of establish an origin on the part. I think we'll probably set this face to be Y0, this edge back here to be X0, and then down at the base of the part where it's sitting in the vice jaws, I'll set that to be Z0 so that this top surface will tell me the height of the part when we trace around it. So let's get started. I'll just manually jog roughly into place. And I'm going to turn on 0 mode, continuous, because I've got a couple of setups to do here. So we'll probe in the Y direction. So that just zeroed our Y-axis. We'll come over here, set up the X. And now we'll go down and touch off on the Z surface. So Z is a little bit different. It's not just a 0 mode, but what you want to do is use this probe to get and set Z buttons here. So to initially establish your part, you want to use set Z, and we're going to tell it that bottom surface we want it to be 0. And so what it does is it references that surface, it sets the ZDRO, and then it sets that box to be equivalent to the height that you're going to record at. But now that we're set, we want to travel up to the top of the part. And basically do a touch off here where we say get Z. And what it does there we go. So what that does is instead of resetting the ZDRO, what it does is it puts the value where it measured it into the Z surface value. And so all these clearance and depth moves that we do are now, if I tell it to go down to depth, turn off our 0 mode. So that is now referenced to that top surface. So to get started, let's go pick up on these couple of hole features. I'm just going to manually position over the hole. I'm going to turn auto Z up down mode, and just as a check I'm going to go to depth here, and that looks like a good depth to reach, so I'm just going to go ahead and make sure we're recording, and we'll do a pocket feature here. And if we look at the viewer, and there's our data. One thing it did do is it put it on the center lines layer. I'm just going to toggle a new layer, which is a good practice. I'm going to call this new layer profile, and it'll ask for a color. Let's give it something bright that's easy to see. And right now there's no good way of transferring geometry from this layer to another layer, so I'm just going to go ahead and retouch that real quick with our active layer being the profile. So there we've created that geometry up on that layer. Let's redo the big bore. All right. So to establish a good edge here, we've got a nice machine to reference surface. Let's kind of eyeball the length. So right, if you remember, this corner over here is 0, 0 for X and Y. So if I travel over to this side, it tells me X, it's about 1.7 inches long. So I'm just going to come over here, roughly position it. We've still got auto on, up, down. I'm going to put it on edge mode. We're going to do it in the Y direction, and we'll say our edge length is 1.5. Looks pretty good because and again, when it's moving this traverse during the clear, that is the clearance feed value here. I could increase that if I wanted. So there's our edge measurement. Shows we're got a little bit of an angle delta there, about 17 thou. So the vise isn't quite square, but this will all transfer in then when we make our DXF and bring it into CAD later. We can use that edge as a reference and align it to the x-axis. If we go back and look at what we got, so we just dropped a line there where we did that probe. So let's do an X probe on the edge. Again, one will be at this and then it'll travel upwards in Y, and it looks like a length of about a little under an inch. So I'll come back here, put our edge length at 0.8, run that. So take another look here. We've got two solid reference edges that we probed at fairly hard. So these are good datums to align when we're using our CAD software to recreate this. And now we want to get the whole overall profile. So let's pick up spot to start, and we'll move our Z down, and let's turn off auto up down Z and travel over to the perimeter probing page. We're going to do this in the XY plane. Again, we'll be traveling around the part in that plane. So we've got our settings here. Those all look pretty good for speeds. Let's increase the feed rate a little bit. We're going to probe upwards at 90 degrees or towards the Y direction first. So all you got to do is click this wheel to set a approximate angle. And let's just go ahead and create a new layer. We'll call this XY profile and do this in a different color. And you know, anytime you do probing, it's going to go into whatever's picked as the active layer here. So I think we're all set. Let's go ahead and tell it to go. So the line's kind of, it is putting it in there. It's overlaid with the green line. We can turn off that profile and see our color there. I picked a bad color, but so there's a little bit of a jog in this part between the machine face and the casting, so it picked up that. And we'll let this run around. I'll probably speed up the video here in a second, but you get the idea. And so one thing I can still point out while we're doing this trace, you can see that the geometry is being put at the same level as the top surface. If you remember, we set the top Z surface value, and that's what is being recorded in the DXF. So even though the probe is below that surface, we told it that we want all the data to be basically recorded at the surface. And again, there's quicker ways to do this than going around the entire perimeter like this. You know, I could have done another edge probe along that edge and on the bottom edge and only done the perimeter trace around just a small portion here, but just for demonstration purposes, I'll just kind of let it run out. And we're just about done. You can see it's coming back around and basically putting all the data right back on the first edge we probed. And it completed the lap. So the only thing I'll note is, you know, sometimes if you start the probing and you get interrupted somewhere, this auto stop after a loop doesn't quite work out. It gets confused as to where you stopped and started. So that can be hit or miss. So there's our whole top profile. We can view it from the top. And that's the shape of our part. So now we've basically got this set up. We'll do a save of this. We'll call this the bracket profile side. And we saved that. We can close that current data file. And we've basically emptied out to an empty file here. And we'll reset up the part and probe it from the top. So we'll be back in just a second. Alright, we're back. I've reoriented the part into the vise upright. And so to finish off, we're going to have to reestablish a new origin for this file. Again, I'll probably choose this lower left-hand corner. Actually, I think we'll make the center line the origin, and then this back edge will be the X origin, and then the bottom face on the vise surface will be what we set up as Z origin. So to get a little bit better view, I'm going to reorient the camera a little bit so it'll be out of plane from the X and Y axis. But so in ProbeIt, again, we're basically starting with a empty data file, and we've got no reference to the part with regards to its origins. So let's start there. Let's go back to our 2D probing page. Let's turn off these for a moment. And we're going to do a set that surface as 0. What is going on here? There we go. I had to clear the set Z. So now that bottom surface is set. Let's travel over to the top of the part and do a get Z. So that right there tells us our part is 1 inch 73 thou tall through that thickness. Let's see, the remainder of the origin, we wanted to set this back edge as X0. So auto up down, 0 mode, probe in X. And that's set. And then I said we would do the center line along this direction, and the Y direction as the 0. So let's set that on. And for a moment I'm going to turn off auto up down because I just want it to do it in place. I eyeballed my height, so I'm going to hit the vice jaws to center it. Probe distance 2 inches should be enough. So let's go ahead and run inner slot. Alright, so now we've set up our origin. So basically the center line of the part is Y0, this back edge is X0, and the bottom face is Z0. So let's start collecting our data. Let's do another edge probe. First thing I'm going to do is set up a new layer. Let's just call this top. And pick a nice bright color. So we're going to do the X as an edge mode again. 0.8 inches. And let's turn back on auto Z up down because I did touch off this surface and I know where I'm at currently. And Z is set. So. Alright, let's take a peek and make sure we know what we're doing here. So there's that back edge. Let's go ahead and do another one with the width. And I'm going to turn off auto up down because I want to do the vice jaws again. The reason I'm repeating this is because the first time when we were setting the axis to 0, we didn't actually take any data. But now we're taking data relative to where we set up our origin. And there's our lines, so that's good. You can see it puts the center line and then the two edges. Now let's create a new layer. We'll call it holes. Make that nice and bright. So I'm just going to jog over each of these holes roughly, auto up down, and run it. There's our hole size, they're roughly 5/16. And if we look, we put in that first hole, I'm just going to jog over next hole, run it. And you might ask, well, what if I accidentally miss and I'm not over the hole when I do the routine? Well, all the entry moves are G31 in the background, so it will hit and stop and retract and notify you that it hit on its way down. So just for instance, if I come over here and I say Z down, it does retract, and if you open up the status, it tells you it hit on a clearance move. So now we've got our two small holes. Let's travel over and get the next larger hole. And this larger hole is actually a counter bore, so we're going to actually do another Z measurement and then get the bottom of the hole. Okay. Get our last hole. Alright, so that concludes all the holes except for the bottom of the counter bores. So what I'm going to do is I'm going to eyeball near the edge, so I'll hit the bottom of the counter bore, and I'm going to take Z set off. And oops, that was my bad. I should not have done that. So I can't do a get Z with that not set. I have to go back and reference off my bottom again. So I'm going to clear that back to 0. Do another get Z. So now I'm going to travel back over to one of my holes, make sure I'll clear the side but hit the bottom of the counter bore. I'm going to do a probe to get Z. So what I did was I set the surface at the bottom of the counter bore. I'm just going to kind of go roughly back to the middle, and you know, we've still got the Z depth relative to this surface set, so I can say go down and run a small bore down inside there. So there you can see we've captured, you know, at the top of the surface of the part we've got the top of the counter bore diameter, and at the bottom we've got the diameter of the bottom of the counter bore. So what I could also do here, just to show you how this works, is let's say I wanted to do a Z depth just above that bottom surface. I could change this to a plus 0.1. And then go back down to my new surface. And I've still got this Z surface value set, but if I do a probe of the bore, so now I'm getting the diameter of the counter bore, but it's going to be put at this surface level. So there we've essentially mapped out the counter bore depth, and then in CAD we know to take this inner diameter all the way through the part. So I'll just retract up out. I'll go down and we're all set. I'm just going to go ahead and run the counter bore diameter on this side. So there's our other counter bore, and let's just get the smaller diameter, I just need to go deeper so I'm in it. So I can just run that again. So it appears not too intuitive the way the buttons are set up here, but they are there with a purpose, you know, so that you can get various depth level measurements and record values at a height which is not the same as where the ball is, because obviously you want to know where the surface is in real space, but the ball has to be above or below it to get the actual geometry. So that pretty much maps out all the hole features on this side. Just as a last demo, there's really no need to do it because we already did it with the part flipped sideways, but we can trace the profile in the XZ direction. So what I'm going to do is come over here and start down a little ways. And I'm going to clear the auto up down, and we're not changing our Z-axis or anything, or the Z-set. We're going to go over perimeter probing and do XZ perimeter. And it looks like one of my buttons moved on me. I'll have to fix that. So we're going to start basically at 0 degrees. All the settings we had before are okay. And I do want to make a new layer here. We'll call this XZ Surf. And let's give this a color. And we should be good to go. And it had a little hang up there, starting kind of close to the corner, but you can see we got to the corner. I'm just going to lift it up, get over the part, tell it to start probing straight down, and restart it. And that's kind of an ugly color I picked. And that interrupted the routine. Let's just go back and restart all of this. All right. So we're going to restart our Z routine here. Create a brand new layer, XZ Surf, and give it a bright color. And we're going to go ahead and make our lines a little bit thicker so we can see them. Turn off the endpoints and increase line thickness. So now we got our XZ surface set up. We're going to start probing in the 0-ish direction here. And let's go ahead and probe this. And I think we're hung up again here. Oh, it says probe is active. It didn't back off enough is the problem. So I'm just going to jog it up. Oops. Get over the part. And let's restart. Getting around corners is going to be a little problematic. And I'll just kind of spin the camera a little bit more into plain view of what we're doing. So again, like I said, there's really no reason to be doing this other than to demonstrate, some of the capabilities of what directions and surfaces you can probe with ProbeIt. We again already got this data when the part was flipped on its side in the XY plane, but we'll be able to take this over to CAD and just show how well stuff lines up or doesn't. And as we get up over the top of the part here, I am going to have to manually stop it. There is no smart way currently. It's going to keep trying to follow until it either can't touch anymore or it crashes the body of the probe. And that looks like a good spot to stop. So we just do that by hitting the abort button. And I'll manually jog it up out of the way. So there, we've basically captured enough data to go recreate this part in CAD. We've got all the hole features, the surfaces referenced back to known edges, and we've done it in 2 different planes with the part rotated and clamped differently. So let's save off this file. And we'll call it bracket profile top. And we can close it.